Hello everyone. In this video, we will be discussing about electrical discharge machining process characteristics, its applications, advantages and disadvantages. So first, when we look at the characteristics of electrical discharge machining, it can be used to machine any work material if it is electrically conductive. Metal removal rate depends on thermal properties rather than its strength, hardness, etc. The volume of a material removed per spark discharge is typically in the range of 1 by 10 lakhs to 1 by 10,000 millimeter cube. In electrical discharge machining, the geometry of the tool positive impression of hole or geometric feature. Tool wear once again depends on the thermal properties of the tool material. Local temperature rise is rather high, but there is not enough heat diffusion. That is very small pulse on time, and thus HAZ is limited to 2 to 4 micrometer. Rapid heating and cooling leads to surface hardening, which may be desirable in some applications. So tolerance value of plus or minus 0.05 millimeter could be easily achieved by electrical discharge machining process. Best surface finish that can be economically achieved on steel is 0.40 micrometer. And moving to the applications, so the major applications only listed here. So the drilling of micro holes, thread cutting, helical profile milling, rotary forming and curved hole for drilling. And delicate workpieces like copper parts can be produced by electrical discharge machining, and it can be applied to all electrically conducting metals and alloys irrespective of their melting point, hardness, toughness or brittleness. So other applications includes deep small diameter holes using tungsten wire as tool, narrow slots, cooling holes in superalloy turbine blades and various intricate shapes. So EDM can be economically employed for extremely hardened workpiece since there is no mechanical stress present, that is no physical contact. Fragile and slender workplaces can be machined without distortion. So hard and corrosion resistant surfaces essentially needed for die making can be developed. So let us see the applications with respect to like a specialized like a name. So first one, let me go with electrical discharge machining sawing. So an EDM variation where employs either a special steel band or disc, and it cuts at a rate that is twice that of the conventional abrasive sawing method. Cutting of billets and bars, so has a smaller curve and free from burrs. Fine finish of 6.3 to 10 micrometer with a recast layer of 0.025 to 0.130 mm. We can able to see in the two sketches where band sawing and disc sawing was taken place. So band sawing means with the help of a steel band, generally a wire, with the help of your feeding and the workpiece, how the dielectric supply you can able to see how it is done. And in case of the disc means you can able to see with a holder where the disc is kept and the feed movement in like this and rotation in clockwise direction. And the disc thickness and the deionized water was continuously supplied for this one. And next one is application is machining of spears. So here Sichun and co-workers in 1995 used simple tubular electrodes in electrical discharge machining of spears to a dimensionally accuracy of plus or minus 1 micrometer, and RA is less than 0.1 micrometer. So here rotary electrical discharge machining is used for machining of spherical shapes in conducting ceramics using the tool and workpiece arrangement as shown below. You can able to see here how the tool has been changed the position from this side to other side with the rotation. And yeah, the table or like whatever we can call like the tank where we will be keeping the tool, in there will not be any movement of that one. Instead of that, we will be keep on changing the electrodes. And the third one is nothing but the applications related to the machining of dies and molds. So electrical discharge machining milling uses standard cylindrical electrodes. So here simple shaped electrode, which is shown in the sketch one, is rotated at high speeds and follow the specified paths in the workpiece, so like the conventional end mills. And it is very useful and makes electrical discharge machining very versatile like a mechanical milling process. And it also solves the problem of manufacturing accurate and complex shaped electrodes for die sinking, and which is shown in the figure 2 for the three-dimensional cavities. And moving to the next one, electrical discharge machining milling enhances dielectric flushing due to the high speed electrode rotation. Electrode wear can be optimized due to its rotational and contouring motions. Main limitations in electrical discharge machining or milling will be complex shapes with sharp corners cannot be machined because of the rotating tool electrode. Electrical discharge machining milling replaces conventional die making that requires variety of machines such as milling, wire cutting, and electrical discharge machining, die sinking machines. But the applications of machining dies and molds. So the special form of electrical discharge machining using a continuously moving conductive wire electrode, where the material removal occurs as a result of spark erosion as the wire electrode is fed from a fresh wired spool through the workpiece. Horizontal movement of the work table, I am talking about CNC, which determines the path of the cut, and the applications may be machining of the super hard materials like polycrystalline diamond, PCD, and the cubic boron nitride CBN blanks and other composite. Carbon fiber composites are widely used in aerospace, nuclear, automobile, and chemical industry, but their conventional machining is difficult. So Kozak et al. In 1995 used wire EDM for accurately shaping these materials without distortion or buds. So recently used for machining insulated ceramics by Tani et al. At 2004. And the application, it is still continuing with the fresh wire which is supplied here with the continuous supply of the dielectric fluid and the direct current with the CNC movement. And moving to the next one, EDM of insulators, a sheet metal mesh is placed over the ceramic material where the spark discharges between the negative to electrode and the metal mesh. So these sparks are transmitted through the metal mesh and to its interface with the ceramic surface, which is then eroded. And the dielectric fluid presence is mandatory here also. So applications in texturing, which is applied to the steel sheets during the final stages of cold rolling. So short blasting is an inexpensive method of texturing. So limitation of short blasting includes its lack of control and consistency of texturing and the need for protection of other parts of the equipment holding the roll. So EDT is a variation of EDM and proved to be most popular. Texturing is achieved by producing electrical sparks across the gap between the roll, that is the workpiece, and the tool electrode in the presence of dielectric paraffin. Each spark creates a small crater by the discharge of its energy in a local melting and vaporization of the roll material. By selecting the appropriate process variables such as pulse current, on and off time, electrode polarity, dielectric type, and the roll rotational speed, a surface texture with high degree of accuracy and consistency can be produced. We shall discuss some of the advantages and disadvantages of EDM. So advantages include complex shapes that would otherwise be difficult to produce with conventional cutting tools can be easily machined in the electrical discharge machining process, and extremely hard materials to very close tolerance also can be done very easily in the EDM process. Very small work pieces where conventional cutting tools may damage the part from excess cutting tool pressure. There is no direct contact between the tool and workpiece, so therefore the delicate sections and the weak materials can be machined without any distortion, and a good surface finish can be obtained. And moving to the disadvantages, so the major disadvantage would be the slower rate of the metal removal, and for economic production the surface finish specified should not be too fine. The additional time and the cost used for creating electrodes for ram sinker electrical discharge machining. Reproducing sharp corners on the workpiece is difficult due to the electrode wear, and this may happen in case the flushing is not done properly, because continuously flushing should be done, which carries away the debris over the workpiece surface once the spark has been directly hitted over the workpiece from the electrode. Because of improper carrying away of the debris, sometimes the debris will be deposited on the surface of the workpiece and further leads to the what is that short circuit, and finally it leads to the sharp corners. And specific power consumption is also very high, so we should invest more money for the power generation. And power consumption is also high compared to the specific power consumption. Overcut is formed, that is excessive tool wear occurs during the machining. So electrically non-conductive materials can be machined only with specific set of the process. So with this video gets completed, and we will see in the next video about the second part, that is plasma arc machining process. Thank you.